Hey there, guys. We're going to review in Prereq 1 lesson. We're going to review a good chunk, a lot of Algebra 1 and part of Algebra 2 here. So the first thing is make sure you remember the real number set. Remember the natural numbers are also the counting numbers. So we know that's 1, 2, 3. The whole numbers, right? I always circle the 0 in there because 0, 1, 2, 3. So we need to be careful as we define between the two. 0 is the big identifier. In the integers, that's where we go with -2, -1, 0, 1, 2. All right, be careful. There are no decimals or fractions in integers, so that sometimes trips up some kids in Algebra 2. I know you had a little break in geometry from dealing with some of these. A rational number, anything that is expressed as a fraction is a rational number, without a doubt. If you have a decimal, it can be terminating, or it might be repeating. Those things are okay. Okay, irrational, your best example, remember, is pi. After that, we're going to use something like the square root of 5, square root of 17. Those numbers that don't work out with that. Okay, so those all make up the real numbers. Remember, you also have the imaginary numbers. The square root of -1 becomes I. That wasn't listed in our chart here, but it might be a good time just to remember that that is something that we can work with in the future here. Okay, so if you need a recap on any of those, make sure you brush up on those. All right, the next one has to do with the order of real numbers. If A is greater than B, A minus B is positive. So what I often encourage students to do is, as we talk about this, if A is greater than B, that means A is on the right. So it doesn't matter where 0 is, doesn't matter anything else. We're talking about the order or the physical location of those. So you want to make sure that we can identify what's happening. So I think this is a great strategy to use when you're talking about an SAT question and you're getting a little bit mixed up with this or that, because often we like to see it as something concrete, and the number line is a place to do that. Okay. We also add in the same situations with the equals to, and that's a vocab situation. These are called inequalities, and you've dealt with those for years and years and years. Opposites in the number line. So when have we used this before? So maybe something like 5 minus 2x is greater than, let's say 3. So here would be an example when we used it before. If you are going to then divide out this -2 at some point, so let's go ahead and do this. -2x is greater than -5, -2, and divide by -2. X is now less than +1. So we had to flip-flop this because we are dividing by a negative. So we want to notice this change right here. Again, you don't deal with that too much in geometry, so a quick review of that as we get started into pre-calc. We have a notation change for you, and this shouldn't be overly difficult because you've seen this in a couple different ways. We know that closed because it's going to have the equals to portion here, and we're used to seeing those brackets. And what we saw in Alg 2 in particular is we used closed points for those ideas. And now what we do in pre-calc is we actually take the brackets themselves and we put them on the number line. So we don't worry so much about open and closed as far as the notation. And if they are parentheses, that means it's going to be open. So it would have been an open circle in Algebra 1 or 2, but here we literally use those parentheses on there. And we can have half open either direction. Okay, so we can make up a couple examples and figure out what you want to do with those over here. So maybe we do -4. Let's go bracket to 2. That sounds good. And we do parentheses. So we're literally going to use -4 to 2, and we'd fill those in between. And so these are going to be with your numerical intervals. So let's go -1 to 3. Now keep in mind that in this one, as we look at the space in between, right, so we have one that is half open and one that is open. Okay, so this is all vocab, circling back to this column in the middle. It really should make it a little bit easier instead of determining if it were open or closed circle, kind of like solid and dashed lines. So just a new notation, and well, you should be okay with it. Okay, if not, let's talk. We'll figure it out. All right, so unbounded. Unbounded just means that you're going to have this go in one direction or the other. So it's simply your greater than, less than, greater than or equal to, less than or equal to. We continue to use that same vocabulary of open or closed for all of these. And we're going to continue to use parentheses for that open and brackets for the closed. So we just try and simplify the entire situation. Again, you can throw some examples in here. I don't want this video to go too long, so please add something in there where it's one greater than, one less than, so you can practice those open and closed. All right, so we run into some basic properties of those real numbers. So you saw this in Algebra 1, Algebra 2. We did talk about it in geometry, so it's been a while. So a couple things that I like to do for the big boys here, commutative property and the associative property. You can see them here on the left, and that would be great and hunky-dory if we remembered that all the time. But if you haven't heard me give this spiel before, here we go. Normally on a school day, you start at home, you go to school, and then you go from school and you go home. All right, so that is your commutative property. So that is 5 plus 4 equals 4 plus 5. Okay, so if you're just switching the order of something, it's your commutative property. So if you've ever had trouble with these, then we want to make sure we clarify that for you. The next thing is, what is the NBA? Well, it's the National Basketball Association. Okay, so the key here is the A part of what do the letters stand for? Association on the end. So that's the associative property. So who do you associate with? So let's say that we have A, B, and C, and A, B, and C. And to start the day, you're going to be letter B for this case. Your best friend is who? Your best friend is A. All right. And then throughout the day, maybe you didn't like what A said, or maybe B gave you that piece of gum or something you really wanted, and now your best friend is C. So you've changed the association. Okay? You can all still be friends. That's fine. Okay? No need for any weird stuff on social media or anything like that. You're all still friends. Okay? But if you've changed who your closest associate is, then that means you've completed the associative property. Okay? So just keep in mind, the commutative property, I will try and trick you just like everybody else tries to trick you, and do something like this. Notice in this example that I put above the commutative property, if you're the letter B, your best friend each and every time is still A. So we didn't change anything except for the order. If I just change the order, then that changes your commute. Okay, so hopefully that clears up those two. Those seem to be the trickiest ones, or the easiest one to try and trick people with. But I won't get you, will I? No, you got this. All right, the identity property, that's when you add 0 or multiply by 1. So that one's not too bad. I talk about it a lot in Algebra 1 and 2 as keeping your identity. What you start with is what you finish with. You kept your identity. The inverse property, these are the ones we use to solve. So if you're a positive u, you add on a negative u, you end up with 0. Multiplication requires division. Okay, so we're going to flip it over, use the reciprocal, so that you end up with 1. Distributive property, I can't believe this one's still in here. You guys completely know distributive property, and you should be able to use that inside and out. Okay. Good to note that all of these are used for addition and multiplication only, and that's basically half of a chapter in Algebra 1. Okay. Let's jump to some notation that we want to brush up on. If we have -3 and we square it, we get +9. I'm going to blatantly make that +9. If I have 3 squared and then a negative here, remember this is like saying -1 and 3 squared. So that's why it's -9. So if you see these two differences, make sure that if you're going to use a calculator for this, you have to use the parentheses with it. So we're trying to identify what is the base. The base here is -5. Okay, so I don't really care what the answer is. The question is, what's the base? The base here is positive 5. Now, how does it impact the outcome? So this one up here is going to end up being negative 5 times negative 5, which is 25. This one here, the base is 5, and it's still multiplied by the negative, so this one turns into negative 25. So this is one thing in Algebra 1 and Algebra 2 that you've been trying to work around for years and years, and hopefully you have the hang of it now. If not, this brush up, I hope, helps. If not, ask me, and we'll talk about it one more time. Since we're dealing with exponents, we want to review all of our properties here. So I want to give you a chance to go ahead and type those in here. So remember, under your draw on the far left, you have this type text. You can go ahead and jump those right in there. Okay, so I have the property and the example. You know, right now, I don't really care if you know the name of the property. I want to make sure you know what to do with it. So I'm going to just try and highlight a few things that we do have the same base and we're multiplying, so that requires you to add. Okay, so notice the base was 5 each time, so you added the exponents, and it makes that a little bit easier. And number 2, since you have the same base and we're dividing, that causes a subtraction of the exponents. And number 3, anything to the 0 power is 1, so it makes that one pretty easy. Okay. Number 4, I like to show this one as a fraction itself, so we know those negative exponents require you to take the reciprocal, and you lose that negative. Notice 1 over u to the n is now positive, okay, where it started off as negative. And again, you've seen those in Algebra 1 and 2, so hopefully this is a refresher. So negative exponents in number 4, and we know we're going to take the reciprocal. It does also work if you have 1 over 5 to the negative second does become 5 to the second over 1, or just 25. So it does require factors from the denominator to move to the numerator as well. Sorry, I couldn't think of that. Number 5 and 6 somewhat go together. We have a power to a power, so we're going to multiply those. So if you see multiple bases, that's where you're going to add or subtract. If you see multiple powers, that's where you're going to multiply. That also needs distributed in number 5 as a backtrack one, that these were both to the first power. So u goes to the mth power and v goes to the mth power. So it is 2 to the 5th and z to the 5th. And that distributive idea does work for fractions as well. So 7 goes to not only a, but also to b. The mth power goes to u and v. Okay, so we would have 6 and 7 both have something to do with distributive property to make sure we have those powers to a power to multiply. All right, so we'll open that up. So make sure you give yourself in your words, right? That's the most powerful way to make sure this makes sense to you, is to put it in your words. So I'm not going to jot anything in there. If I went too fast, just go ahead and review that by rewinding. Or we give you a chance to work on a couple of these. I just took these and made sure you had a little more space to work them out as you go through. Notice nothing has an extra power on it. So we're simply going to do this in 3 separate problems. 2 times 5 is 10. That's not new to anybody. A and a to the second, I have multiple bases, so it becomes a to the third, right? Because we have 1 to the first power right there. And b is going to end up, here's 3 and here's 5 more, so that's to the 8th power. So it steps us through each one of those. Same thing with our division. Remember, these just turned into multiple little problems. So if I have 2 minus -1, remember that's 2 minus -1, that's 3. And here we're going to have -2. -2 minus 3 is -5, so v to the -5th. Remember, as you do the straight rule of subtraction, everything goes in the numerator. So final answer is u to the 3rd over v to the 5th, because v had this negative exponent. So we got to move it to the other half of the fraction. All right, in letter C here, we have to distribute that -3 to each one. So it becomes x to the -6th over 2 to the -3rd. So we'll get 2 to the 3rd over x to the 6th. And hopefully by now you know that 2 to the 3rd power is 8 over x to the 6th to give us our final answer. So we can work out a lot of those rules. All right. Yep, we're still going here, guys. So if you're working from home right now and you need to take a little break before we do scientific notation, I don't think there's too much more. And hopefully this is all review. So define restriction of the variable. A, this number here, that has to be a rational number. And n, the exponent we're going to use, that has to be an integer. Again, if you don't like the handwriting in there, you can always use text boxes as well. So go ahead and use those. So we're going to just write a few of these in scientific notation. Keep in mind where you want the decimal point to go. And I usually use a bar in there so you can see. So that means we want it to start off as 2.341 times 10. This is a very small number, right? 0.002, so I need 1, 2, 3 places. And since it was small, I'm going to make it negative, right? That's how we make those. The next one is already somewhat in almost a scientific notation. Remember, this a value has to be between 1 and 10. It can be 1. It has to be less than 10, not equal to 10. So this would be improper scientific notation. So to get it in proper scientific notation, I want to figure out where the decimal point should go. So again, I'm going to use this vertical bar. So that means it needs to move 2 places. So I'd like it to be 5.3121 times 10. Now here's what I do, is I say that this number, 531, was too big, so I do a plus sign on the 3, and I had to move it 2 places. So now it's 10 to the 5th power. I know in science class, sometimes you talk about left this, right that, and subtract, add, subtract. I get confused with left and right. I'll be honest. So I just say if the number is too big, add on to it. If it's too small, subtract it. Okay, so that's what we're going to do here. So we know we're going to be between the 1 and the 2, so 1.23 times 10, and we have to go back 1, 2, 3, 4, 5, 6 places. So I'm going to go minus 6 on the 12 to make it the 6th power. And now it's in proper scientific notation, which of course helps us order these if we need to put them in order, least to greatest or anything like that. All right, so we left one here. We're going to try and do this without a calculator. So we want to make sure you can move everything around. And you can see I have in your OneNote, just erase the ink to check. Okay, so we want to use scientific notation. So we want to get each one in proper scientific notation. That way you could do your multiplication of your A values a little bit easier, and then finally your division. So I tried to leave some of it showing here, and then you want to go ahead and check your answer. So that might be one item we could talk about in class. One thing I want to point out, if you're using the graphing calculators or even scientific, I want to make sure we point out that this 9e10, that means 9 times 10 to the 10th. Okay, so that's what would happen here as we try and get these answers. Okay, so make sure you can translate your calculator into an actual answer as we need to. I know, again, in geometry, we probably don't use numbers of this size very often. So a quick refresher on scientific notation. All right, we do have a problem set. That would be from the textbook, and I'll have that posted in Schoology based on what needs to be done there. So I know that was quick. Please review any section you needed. That's why I didn't do this as an ed puzzle. So you can grab any part you need, rewatch it, find out if there's anything that you need some extra help with, and we'll talk on the days you are in class. All right. Hope it was informative and all review for you. If not, we'll get it done. All right. Peace.